Thanks and welcome back. Mr. Newbold, where'd you go? We're about to do quadratics or parabolas. Where are you? I'm right here. What's up? We're doing parabolas. Go Weber. So we are doing parabolas to help you out there today. And doing quadratics is another word. Quadratics or parabolas. Parabola. Okay, here we go. So I only got a couple graphs there to graph on, but really you can use your graphing software to help you graph it on the calc. First thing I'm going to do to help you on this assignment, well, we'll just jump right into it. Here we go. So that first one, here we go, we factor it. And so to get the roots, you have to factor it. Yeah. So that factors into x and x and 1 and 3. Because factors of x squared are x and x, factors of 3 are 1 and 3. And then we have, let's see, so the sign of the middle term, which is a positive symbol, goes with the bigger number. Just saying, when you have opposite signs, opposites attract. When you have opposite signs, make an acronym. You have opposite signs, yes, a positive goes with a bigger number. The reason why is a positive 3 with a negative x, so that would be 3x minus 1x, right? 3x minus 1x is 2x. Cool. So now we take our factors and set them equal to 0. Take our factors, set them equal to 0, solve for x. So we add 1 to the other side, we get 1 as one of our roots. And we also minus 3 to the other side, and we get negative 3. So those are our roots that we're going to use. Now to find the vertex, to find the x value of the vertex, you got to use a formula, okay? So use a formula. The formula is x equals negative b over 2a. It's kind of like the quadratic formula. X equals negative b plus or minus the square root of blah, 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 all over 2a. So it's part of the formula, which we'll get to. So then we're going to do x equals, and so basically you go back to the original, which is this guy right here. And so this is your what value number that's there. It's divisible to 1. That's your so that's your a. The 2, that's your b. And the 3, that's your C. So these are your these are your ABCs. So these are your ABCs. And so negative b would be this one right here, so negative 2. So we're going to use that number. And so we'll do negative 2 all over. 2 is the, so 2 is actually the formula, 2a. So negative b over 2a. So it's going to be negative 2, which I'm going to color code this. So negative 2 from this 2 right here, right? Over 2 times 1. Where'd that 1 come from? That was the invisible one right there next to the x. And then the formula is x equals negative b, negative 2 over 2 times a. So this is the formula 2 right there. Okay, so then negative 2 over 2 reduces to negative 1. Nice. And so that's our x value. Now to find our y value, you have to plug it back in. You have to plug x back in to, so you have to plug x back into the original. Back into the original. Calculator for that. I'm going to erase the formula because hopefully you have it memorized. I'll put it up here though. So you should write it probably on the top of your paper. So use the formula. Okay. And then we'll go ahead and move this up here because we solved for x. So now we're going to go y is equal to, our original formula is x squared plus 2x minus 3. And what we're going to do is wherever we see an x, we're going to go ahead and plug it in, okay? So we're going to plug in that negative 1. 1. So wherever we're seeing x, so we're going to plug in a negative 1 there, and plug in a negative 1 there. So let me go and put parentheses to C. So in place of x, right, this is like substituting in place of x. So in place of x, so originally, right, originally you had an x. So originally you had an x in there, and we're going to take that out, and in its place, we're going to plug in the negative 1 there. Good. And then over here, we'll also plug in the negative 1. Cool. Okay, so then we multiply that out. We get negative 1 times negative 1 is a positive 1. Negative 2 times negative 1 is a negative 2 minus 3. And so that's negative 2 and negative 3 is negative 5, with a plus 1 is negative 4. So the y value is negative 4. So we'd say x equals negative 1, and y equals negative 4. And that's our vertex. Now, here's the trick. Here's the trick for these problems, right? So you're going to take that negative 4, which is your y value, right? If we're going to graph this, up here, we would go back 1, down 1, 2, 3, 4. And because this is a positive, not a negative. So negative means upside down, which I changed for number 6 this year. So negative means upside down. Otherwise, it just goes upwards. Parabolic goes upwards. So basically, you're just going to go upwards to infinity, upwards to infinity. And so the range is going to be that y value, right? Y equals negative 4. Remember, it goes down to up is the range. Down to up. So down to up. So the range will be negative 4 to infinity, down to up. And the domain for all these will be the same, because you're basically going this way forever slowly, and you're also going this way forever slowly. So the domain will be negative infinity, positive infinity, negative infinity, positive infinity. For all these quadratics, just like absolute value, negative infinity, positive infinity, negative infinity, positive infinity. For number 3, for number 4, for number 5, for number 6, negative infinity, positive infinity, negative infinity, positive infinity. Negative infinity to positive infinity, all real numbers. Right? For the domain, that's for the domain, all real numbers. Now that's for the domain, not the range. Whoa. Okay, now the range again, the range is going to be the y value. What the? Why does it keep doing that? Sorry. Okay, so the range is going to be the y value of the vertex, right? The y value of the vertex to infinity, basically. I think it changes with 6 a little bit, because I think it goes the other way around with negative infinity upwards to the number. But that's basically the gist of it. That's basically the idea. I'm going to jump to 5, because it has a crazy answer, but try number 2, 3, 4. Don't forget for number 4, you got a minus 12 that goes, no, the other way. You got to go down the same side, so we're going to minus 12 this way. And so you're left with the 5x squared minus 10x. Wow, and those just go away, equals 0. You're going to have to do single factoring. So single factoring means we pull out the GCF, the greatest common factor. So we're going to pull out a 5, and we're going to pull out an x. And when we single factoring out that 5x, what do we have left? 5 divided by 5 goes away, it becomes a 1, it goes away. X squared, there's 2 of them, so one of them cancels in the bottom, we're left with an x. Minus 10 divided by 5 is a 2, and the x's cancel. And so, yeah, so we're left with 5x as a single factoring and x minus 2. And then you set each of those equal to 0. You set each of those equal to 0 to get your roots. Add 2 to the other side, so you get x equals 2. Divide by 5, and so you get x equals 0. Nice. And then don't forget to plug back in your formula. This one does have an a and b still, so x equals negative b all over 2a, where our negative b is actually a negative 10 over 2a in the bottom, which is a 5. Wow. And so we end up with 10 over 10, which is just a 1. So our vertex is just going to be at a 1, it looks like. Again, this was our a value, 5. And then this was our b value, negative 10, right? So just to kind of point that out, this was our a and our b. Good. So hopefully that's making sense. Hopefully that's making sense there. Good. Okay. Then you have to plug it back into the original. So you go 5 times 1 all squared minus 10 times 1. And the 12 went away, so we're not worried about the 12. And so 1 squared is just 1. 5 minus 10 is negative 5. Oh, what was this? Yeah, so 1, we plugged it in here and here into the original equation. And so our x value is 1. We plug it in there, we get 5 minus 10 is a negative 5. Interesting. So negative 5 is our vertex for our y value. Okay, but the real one I want to focus on is this one. It's already factored for you, huh? So we're just going to go ahead and do a c plus 6 equals 0 and c minus 7 equals 0, right? And we're going to minus 6 to the other side. So we get c equals negative 6 as one of our roots. We're going to add 7 to the other side. So we get 7 as one of our roots. Okay. Now to be able to do the vertex, kind of two ways to think about it, but you can multiply it all the way through and use your ABC again. C times C is C squared. 6 times negative 7 is negative 42. And then don't forget those are your eyes. Don't forget your nose and your mouth, right? So we have 6 times C is a positive 6C. And negative 7 times C is a negative 7C. And if you combine those together, you took 6 apples off. No, you gave me 6 apples, and you took 7 back. What the? So you took 7 apples, negative 7 apples off my tree, you gave 6 back, so you still owe me 1. So C squared minus 1C minus 42. Why did I do that? Because for the vertex, I need my A value, and my A value again is the invisible 1 there that's next to the C. And then here's my B value, right? B value is equal to negative 1. And so then I go x equals negative b, so negative 1, all over 2 times a, where our a is a positive 1. Again, showing you where I got that positive 1 right here, that was our a value. And then showing you where I got that b value, which was from this negative 1, which was in front of the c there. We should have not called that variable c. We should have called those x's. That's ridiculous. Anyways, because ABC, when you're doing the vertex, okay, so then we get negative times negative is a positive 1 over 2. So we get x equals 1/2, and now we have to plug that in. Highly recommend you just use your calculator, because you're going to have to do 1/2 plus 6, right, times 1/2 minus 7 when you plug 1/2 back into the original, and back into the original to get the y value. And so I would really just use your calculator. You could also plug it in for the squared and the plus or minus 1c minus 42. Okay, let's do it. So you're going to get a crazy number. That's why I'm doing this with you. So we go 1 divided by 2, good, plus 6, good, close parenthesis, times 1 divided by 2 minus 7. And we get the crazy number, negative 42.25. We're going to go to the math button, fractions. Turn that to improper fraction. So that's going to be our y value, negative 169 fourths. Negative 169 fourths. So that was a crazy one. And our range will be down at the bottom at negative 169 fourths up to infinity. And that was just lame. That's why I wanted to show you that one and help you out. Number 7, create your own. Okay. Number 6, we're actually going to change it this year. So that's actually not number 6. So I changed it to make it more of like one you might see on the test. And so that's going to be a negative x squared minus 8x plus 8. Oh, there's a 2? Yeah, there's a 2 in there. And so what I would do is I would go ahead and factor out the 2, so we have a negative 2 actually, and we're left with x squared minus 8x plus, no. Because what you're doing is you're pulling out a 2 by dividing it out, dividing it out. So you're left with like a 4x plus 4, there we go. And then that factors into our roots, x and x, and then factors of 4 are 2 and 2. And both of them are negative. And so we actually have 2 roots there that are the same number. What? So we add 2 to the other side, helping you way too much on the homework here, but I want you to ace this. So put 2 and 2 on canvas just to make sure we get that right. Now the negative means that the range is going to change. The graph is actually going to go upside down. Can be found. So that's what the negative means. The negative means is that the graph is going to be upside down. And so what that means when you do this problem is that the range is actually going to go from negative infinity to the y value of your vertex. So it's going to basically be like this. The graph's going to be upside down. And so whatever you find you got to find it. Right? You got to do the x equals negative b over 2a. Use that formula. And then plug it back in to get the y value. So that means the range is going to be from negative infinity up to that y value of the vertex. Cool. So tune in for the back side. Thanks for watching. Peace out. Thanks for watching. Bye for now. Woo! Yeah, go Weaver.